This is section 3.9, part B. We just looked at one of our properties of logs, the power property. We're now going to look at the other two, called the product and quotient properties. Here's the product property. It says that if you take the logarithm of a product, x multiplied by y, that's the same as the log of x plus the log of y, provided I stay with the same base, of course, all the way through. We're going to go ahead and make up a problem that would allow us to at least check and see that this works in one example. So I'm going to say, let's start with the logarithm, and I'm going to go with base 10 because that's easy to get to on my calculator, of, let's go with 4 times 5, or 20. It's about 1.301. Now, if the statement is true, I should get the same answer if I do the logarithm of 4 plus the logarithm of 5. Let's try that. And there we go, once again, right out to the very last decimal place that the calculator shows. We're getting the same result, about 1.301. So these are the same. And our product property seems to work, at least in that one case, and you could make up many more examples and show that it works every time you try it. All right, let's do something similar here for what we're going to call a quotient property. The logarithm of a quotient, x divided by y, is equal to the logarithm of x subtract the logarithm of y, again provided that we keep the same base throughout. Let's check one of these out. Let's go with the logarithm of 30 divided by 6, or the logarithm of 5. It's about 0.699 approximately. Now, if this quotient property is true, I should be able to get the same answer by taking the log of 30 and subtracting the log of 6. And let's try that. And once again, there's that exact same number all the way out to the end of where the calculator shows us, but about 0.699. So although it doesn't really prove for all values, it shows you, at least by example, that our product and quotient properties seem to hold true. Okay. Just for our convenience, here's a list of all three of our properties in this little chart. Power, product, and quotient properties, all listed out. Okay. The forms that we have actually have names. The collected form is the power product or quotient form. The expanded form is when we bring that power down or separate the product into a sum or the quotient into a difference. There are different reasons for wanting one of these over the other. We'll see some of them in this class, but for those of you who are preparing to take higher level math, you'll learn that in other classes that there are specific reasons for both of these forms. So here we're going to learn to work with them. We're going to learn to go back and forth between the two forms, and then we'll see that actually one of those forms is more useful to us in this class than the other. So let's just start by working on going back and forth between the two forms. In this first set of examples, I've given you a collected form, And I want you to write the expanded form. So looking at this first example, I see a quotient. I know I can expand the quotient into subtraction, or a difference of 2 logs. So I'm going to start with that. It would be the log base 6 of x cubed, subtract the log base 6 of y to the 5th. Now I've got these 2 powers that I can use my power property on, so I'll do that. I can bring the 3 down in front, minus I can bring the 5 down as a multiplier here. And that's completely expanded. I can't combine since they're not like terms, and so I'm done. Okay. We'll do a couple more. The log base 2 of this quotient. That would be the log base 2 of x, subtract, by the quotient property, the log base 2 of 8. In fact, I can go a little bit further with this one, because the log base 2 of 8 is something I know. Here, remember, you're really asking yourself 2 to what power equals 8? And that would be 2 to the 3rd power, right? So the log base 2 of 8 is just 3. And that would be expanded and simplified form. In number 3, we again have a quotient. So I'll start by applying my quotient property for logs. I'd have the log of 10, subtract the log of y cubed. And once again here, I have a recognizable log. This one is a log base 10, a common log. So it's saying 10 to what power equals 10? That would just be a first power, right? Minus, I'm seeing a power property here. I can take that 3 and bring it down as a multiplier on the log base y, or log of y. All right, in number 4, I have a square root on this entire thing. When I see that, I think, well, square roots are really 1/2 powers. And since I'm working with power properties, it would be a good idea to rewrite this as that 1/2 power. I can now say, yeah, that's great. I got a power property. Let's take that 1/2 and let's bring that down as a multiplier in front of the log. All right. I now have a product inside my parentheses. So for the first time, we're going to go with our product property. I turn my product into the sum of logs. This 1/2 out here is actually a multiplier on everything, so I'm just going to keep it out there. And then I would have the log base 3 of 3 plus the log base 3 of x to the 5th plus the log base 3 of y. Okay. 3 factors there, so I separated all 3 into its own log. All right, we're almost there. Log base 3 of 3. That's something we can do, right? Three to what power equals 3? That would be 1. Right here I see another power property, so I'll bring that 5 down in front. 5 times the log base 3 of x. And nothing I can really do there, so I'll just leave that as the log base 3 of y. You can actually leave that one the way it is, or you can distribute the 1/2 and make that a 1/2 plus 5/2 log base 3 of x plus 1/2 log base 3 of y. And that would be the completely expanded form. All right, in these next two problems, we have a combination of products and quotients going on. In number 5, I see multiplication on the top, so that's a product, but then clearly there's division with a quotient as well. I like to start with the division. So let's begin by saying, all right, right where that division bar is, I'll separate that into the difference of 2 logs. So the log base 5 of the numerator, 25w to the 8th, divided by the log base 5 of the denominator, the cubed root of z. I'm now going to deal with the product. There's multiplication right here, so I can separate that into the sum of 2 logs. The log base 5 of 25 plus the log base 5 of w to the 8th, and then minus the log base 5. And again, when I see a cubed root like that, I'm thinking, well, I know that's a 1/3 power. Since I have a power property, it's probably a good idea to write that as the 1/3 power. All right, the log base 5 of 25, I know what that is. 5 to what power equals 25? That's 2. I have a power rule right here. I can make that 8 times the log base 5 of w, minus, I have another power rule right here. I can make that 1/3 times the log base 5 of z. And there's my expanded form. All right, one more example of expanded form. Once again, I'm going to start by concentrating on the division. I'm going to break that up into the difference of 2 logs. So I would have the log of a to the 4th subtract the log of b squared c to the 9th. I'm going to leave the log of a to the 4th for now. I definitely have a power property there, but I think I'm just going to wait and do that in a little bit later step. And right now I'm going to concentrate on the fact that that's multiplication, so I can use my product property. When I subtract, notice I'm subtracting the entire thing. So I'm going to use brackets. That would be the log of b squared plus the log of c to the 9th, all getting subtracted. Now I'm going to go ahead and, actually I'm going to do a couple things, but I'm going to start with my power property. That would be 4 times the log of a. And I'm going to go ahead and distribute that minus sign as we come through here. So I'd have minus 2 times the log of b, and distributing the negative, minus 9 times the log of c. And there's my expanded form. All right, so that's expanding. Let's go ahead and go the other way as well. I would like to look at, given expanded form, can we collect and get the collected form of our logarithms? So in example 1, I have a sum. I know I can put that back together with the reverse of the product property. This would be the log of 3x multiplied by 2x. Or the log of 6x squared. I actually can't do anything more with that. Remember that because the square is only on the x, not on the entire 6x, I do not have a power property. I cannot bring that down in front. And in any case, I wouldn't want to, because I like to leave my exponents as exponents in the collected form. So that one's done. Let's do the same sort of thing here. I've got the log base 5. And I can rewrite that sum by collecting my logs as x plus 3 times x minus 3 inside a single logarithm base 5. And I'm going to go ahead and multiply that out. That would be x squared. Notice the outer is negative 3x, and the inner is positive 3x would cancel each other out. And that would get a minus 9. And again, that's done. I've gathered 2 logs into a single logarithm. In number 3, we have subtraction. That's the reverse of the quotient property. So I'm going to take my log base 8, and then I'm going to combine these as 9w divided by 3z. Simplifying in that fraction as much as I can, really all I can do is reduce the 9/3 and make that a 3w divided by z. And again, I've collected. I've changed 2 logs into a single logarithm. In number 4, we have something new happening here. We've got some multipliers on our logs. When that happens, you always want to use the power property first. We're used to taking the exponents and bringing them down as multipliers. We're now going to do the reverse and take the multipliers and put them back up as exponents. So I have the log base 2 of a to the 8th power minus the log base 2 of c to the 3rd power. Now that I've done that, I can say, okay, I've just got logs without any multipliers. Now I can apply my quotient property. And I can say this would be the log base 2 of a to the 8th divided by c to the 3rd. And once again, that would be considered the collected form. Started with 2 logs, collected them into 1. All right, let's do that again in number 5. I have multipliers, so I need to start by saying let's put those back up as powers. Log base 5 of 2x, the entire 2x raised to the 3rd power, minus log base 5 of 4x, and again the entire 4x raised to the 2nd power. I'm going to go ahead and do those exponents. 2 cubed would be 8, x to the 3rd, and 4 squared, that would be 16, x to the 2nd. Now I'm going to bring my 2 logs and combine them into 1, It's subtraction, so I know I have to use the quotient property. And this time, since I've got the same variables here, I can go ahead and simplify a bit more. Let's see. 8/16 would simplify to 1/2, so I've got a 2 in the denominator. And x to the third divided by x to the second, I subtract those exponents and just get x to the first. So my simplified collected form is just log base 5 of x over 2, or you could write it as log base 5 of 1/2 x. They mean the same thing, right? Either answer would be fine. All right, one more. In number 6, I do have one multiplier, the 5. I need to move that up and put it back in the exponent. So I have the log of p to the 5th plus the log of p plus 4. These are added, so when I bring them together, collect them, I'm going to have to use the product property. I'd have the log of p to the 4th multiplied by p plus 4. I can definitely multiply that out. I'm going to distribute that p to the 4th. So I end up with p to the 5th plus 4p to the 4th as the argument of my log function. And I can't really do anything else with that, so I'm done. All right, so there's some practice just expanding and collecting logs. In our next part of this section, we'll look at solving equations and which of these forms is more useful for that.